Okay, so this question is linked to two linear simultaneous equations, um, but with an unknown coefficient. And in this case, we are required to find the value of that coefficient such that these simultaneous equations will have no solution. Now, we're used to two linear equations having a solution, right? So first, let's understand the conditions under which there would be no solution. So I'm just going to uh, do a little example here. So if I said to you x plus 2y equals 3, and I also said the other equation is x plus 2y equals 7, what's going to happen here? Well, if we attempt to solve this um, by, let's say, the process of elimination, we could subtract the top one from the bottom one, we'd get naught, because you go x minus x is naught, 2y minus 2y is naught, and then 7 minus 3 is 4. And whenever you end up with a situation like this, where it's an impossible idea, then we can say that there's no solution. Okay, so what are we actually looking for then? Clearly, this happens when we get either the same coefficient. I mean, we could also have, I could also have started like this. So let's do another one. Let's say x plus 4y equals 6, and I could have, let's say, 2x plus 8y uh, equals 5. Okay. Obviously, if I do the same thing and I subtract, I'm just going to get an x and a y term. But if I multiply the top by 2, then I'm going to get 2x plus 8y equals 12. And I end up with the same scenario, don't I? I end up with naught equals a number. So what we can see then is that if these are the original two equations, that if the coefficients of x and y are either the same or one is a multiple of the other, then you are going to get no solution. That is, if and the constant term obviously mustn't be the same. All right, so what we can see here then is that I can just see, or I can choose a value of a that would then make the coefficients of the second equation a multiple of the coefficients of the top equation. So it looks like a is minus 6, such that the multiple of the top is minus 2 times the coefficients of the equation below. So option C is the answer. We could also look at it as these are two straight lines. Okay, so when do we get no solution is when the two straight lines, of course, are parallel, i.e. they have the same gradient. So if I rearrange these equations, I would get 4y equals 12x minus 2, i.e. y equals 3x minus a half. And if I did the same to the other one, I'd be getting 2y equals negative ax plus 7, and therefore y equals minus a over 2x plus 7 over 2. And therefore, what I can see is then for no solution, I want this gradient here to be equal to that gradient. So therefore, minus a over 2 equals 3. That would give me a is, again, minus 6.